All right, we got them all? Okay, normally, first quiz, a lot of new kids, particularly in this room. Second hour, it's like at least half of them are veterans, been here before. Just more time telling you how it's going to go, how the review is, what's open, what's not, all that kind of business. So I just got hosed out of a few minutes yesterday. It happened. Typically what's going to happen on review quiz day, come in ready to rock. You do your daily quiz and homework questions. Usually there's not many. Everyone knows the drill. Hand out the review, speed run through it, and you get like 45 plus minutes to work on it. Okay, last time we only had about a half hour, and it was about a, by my count, 27-minute-ish quiz. So we were up against the wall, and we just didn't have as much time as I would have liked for our newcomers. So, yeah, moving forward, it should be, if you've been here before, you know we're usually done with plenty of time. You got those one or two slow pokes who are, trying to squeeze every inch out of it and double checking, triple checking their answers. Maybe they take a little bit longer. Those will go in as soon as I can. I can't guarantee you when I can because I live with domestic terrorists. So, we'll see. Y'all got 07 out ready to roll? Okay. Tomorrow, you get a new packet. We just start into one. There's no hit the end of the chapter, do a test. It's just 5 days, do the thing. 5 days, do the thing. Okay? So, who had Algebra 2 last semester? It was a good chunk of you, right? Okay. So, what we found out at the end of the semester was anyone who had Algebra 2 last semester most likely had Algebra 1 during the Spring 20 shutdown, which meant you never saw any probability statistics at all. I know Ms. Work, Mr. Spear, and we all just kind of scrambled to cram in as much prob stats as we could. My class, we even cut our final in half and just kept our foot on the gas all the way up until one of our days of finals was actually another lesson. Just trying to make sure that you saw the stuff you needed to see. So today, probability statistics, this is all supposed to be, I've seen this multiple times review. If there's anything that I'm going through fast and you haven't seen it before, you better stop me. Because it's just assumed you've done all this before. Okay? Let's see. A basic vocabulary, experiment, sample space, independent, dependent events. An experiment is just when you control variables, determine trials, determine what's a success or failure. And it doesn't have to be like legit someone with a lab coat pouring stuff in, making things blow up experiment. An experiment can be something as simple as, I see a room full of 24 kids. My experiment is how many kids are wearing jeans. And I observe that. I define wearing jeans is success. Not wearing jeans is failure. Record my data. There are 24 trials. Okay? So it can be as simple as that, just an observation, or it can be a little more intense. Sample space is all of your data collected. Can we define independent and dependent events without using the word depend? Incorrect. Come on. What's the difference between being independent and dependent? Okay. Independent, think about independent and dependent variables, right? Independent is the one you control because outcome 1 does not affect outcome 2. In a dependent series of events, the first outcome affects the next ones. The following ones. Think about the classic example is the bag of marbles, right? If I got the big bag of marbles, there's orange ones, green ones, and blue ones in there. What's the probability that I pull out a blue one? I put it back. What's the probability I pull out a blue one? Should be the exact same, right? Because what happened the first time does not affect the second time. Dependent events are where I pull out the blue one, I set it aside, what's the probability I pull out the blue one? Now it's changed. There are 24 kids in here. What's the probability that I pick a student at random to kick out of here and go to the cabin? And it ends up being Brooke. 1 out of 24, right? Now, if she gets kicked out of class and I say, all right, I'm going to spin the wheel and do it again. What's the probability it's Caden? Now it's 1 out of 23. He actually has a slightly higher chance of being picked at random. Okay? So that's the difference between independent and dependent events. Fundamental counting principle, we talked about this in several classes. You should have seen it all the way back down to middle school. Y'all ever done the problem where it's like the menu? You can get a burger or chicken strips or a hot dog. Your side dish can be fries or a salad or apple slices, something. And then your drink can be a pop or chocolate milk, water. Now I'm just starting to read off what the kids' menu is at Culver's. And then it would say, how many different meals can you make out of that? You remember having to list them all out? Like burger, fries, pop. Burger, fries, chocolate milk. Burger, fries, and then it was burger, onion rings, this. Like you had to list all of them out and it sucked. And then your teacher said, hey, you know, you can just multiply these. That's fundamental counting principle. It says everything you have in those categories, if I have 5 main dishes, 4 sides, 3 drinks, take 5 times 4 times 3. Done. So 1 and 2 right there show me that you understand fundamental counting principle and you can read the problem. How many of category A times how many of category B times how many of category C? Multiply them out. You have that many options. Six, 12, 8, 48, 48, 12, so 48, 12, 12, 144, 144, 4, 400, 165, 65, 76, Who had 576 for the first one? How many times did we get caught? Got. Because all we did was see numbers and we just multiplied numbers and didn't bother reading the rest of it. You forgot. Soup or salad is a category. You need to multiply that by another 2. Sound a little bit better? So what's that? 1140, 1152? Okay. Part B, this is what started leading towards the idea of a factorial. You're arranging 5 books on a shelf. You can place them in any order. How many ways can you do that? Well, 1, 2, 3, 4, 5 spots on the shelf. How many options do you have for the first one? But I have now put a book on the shelf. 4, 3, 2, 1. Y'all remember what that's called? 5 factorial, not 5. 5 factorial. Okay? A factorial means this number multiplied by every natural number below it. Okay, specifically every natural number. Because remember, whole numbers also include 0. Integers include negatives. I don't want to do that. So factorial is also one of the few ways that you can just make your calculator quit because the number's too big. Factorials get really big really fast, like even faster than exponentials. I forget where the cutoff is. It's not too bad. It's, a couple hundred, I think, where the calculator just quits and says, no, I ain't doing that. Overflow error. Because factorials can get very large very fast. Now, in this case, 5, 4, 3, 2, 1. So 3, 6, 20, 120. Okay. Poke, poke. That one was also called a permutation. Permutation is when order matters. In fact, that's kind of the big important words. If you're a little fuzzy on this, that's the thing you got to remember. Permutation is when order matters. And they're going to have some word that indicates there's an arrangement of some kind. They're going to say, how many ways can I arrange these? How many ways can they be chosen in first, second, and third place? How many ways can they line up from shortest to tallest? There'll be words in there that indicate a ranking or a hierarchy. That means it's a permutation. Now, permutation, y'all remember this guy. Okay, NPR. Besides being one of the few objective news sources we have left in the country, NPR means N things arranged are at a time. So if I've got 24 kids in here and I ask, in how many ways could we end up with first, second, third, fourth, and fifth place in a competition? I would choose, there are 24 kids, permutation, 5 chosen. Well, 24 factorial is 24 by 23 by 22 by 21 by 20 by 19. Screw you, dude. By 18 by 17 by 16 by... Look at what the next one is. N minus R. 24 minus 5 is 19. 19 factorial is 19 by 18 by 17 by 16... Because those are all canceling. And this is just like if I were to write it out old school, how many ways out of 24 kids could we have first through fifth place? Well, 1, 2, 3, 4, 5 places, 24 possibilities for first place. If first place is already taken, there's 23, there's 22, there's 21, there's 20. The permutation button is what allows me to shortcut that instead of having to write it out. Now, I don't know where everyone's experience was, but who in here had to write these out longhand at some point in your mathematical career? You had to write out all the factorials. Okay? So that's an indicator that you never did it in Algebra 1. Because that's usually how we teach it in Algebra 1 when we first learn it. After showing you that for a day or two, then we show you where the button is. Okay? Find the button. Whatever calculator you're using in this class, Can you find NPR button? Do you remember where it is? Okay. On TI-84, it's in two places. Way number 1. And this also goes for TI-83s. Who's got the ancient one again? I know Jaden's got the 83. Okay. On the 83s, it's just math, and everything's over in the probability menu. Okay. Now, if you do this on an 83 or some of the scientific calculators, it won't have those boxes to fill in. The way you would have to type it is 24. You hit the NPR button, it just jams a P in there. 5. And if I'm going to do anything with it, I got to remember to throw parentheses around it. Otherwise, it'll start trying to smash those together in those subscripts. Okay. For our veterans, where's the shortcut? Alpha. Okay. The alpha shortcuts on a TI-84 Plus or better are really the only big difference. That and the menu pop-ups are the only difference between the 84 and 83. Alpha y equals, all of these here, like this. All of these correspond to these. So alpha y equals brings up fractions. Alpha zoom brings up my matrices, so I can enter a matrix right there on the screen. Alpha trace brings up all of my y's where I can input functions. I'm going to use that for regression models. Alpha window brings up all of my most commonly used functions, the most commonly used operators. Absolute value, summation. You've probably seen that notation before if you haven't really worked with it. You should at least, hey, I recognize that guy. I've seen him somewhere. Derivatives and integrals, calculus. Log base, we got that last year. Our radicals, NPR, NCR, and factorial. So I would NPR, say 24 of you, I'm choosing 5. And there's a lot of ways that out of 24 kids, we can have 1st through 5th place. There's a lot. Okay. So there's permutation. Answer the questions. Both of them are permutation. Both of them order matters. Particularly, I want to see who remembers how to do B. Part A goes back to Algebra 1. Part B was new from Algebra 2. Remember, test daily quiz. Quiet. Do your own thing. Right now, talk. Chat it out with your neighbors. Argue. Okay. Have a discussion. Particularly Part B. Let's see who remembers how to do it. What is the code? 7-digit code. Ways can I choose a code? 10.
They can always draft this.
Who got there? Okay, so sounds like we need to review combinatorics. How many different codes are possible? Well, I have 1, 2, 3, 4, 5, 6, 7 lines. I have 10 total digits. Each digit can only be used once. So 10, 9, 8, 7, 6, 5, 4, which is 72, 20. It's a lot. So I can either do that, or I can just say 10 things, permutation, because order matters. I'm choosing 7, which is big number. Tell me a big number. 600 mutter mutter something for? 604,800. Okay. This is the total number of ways a code can be generated. If a code is randomly generated, what's the probability the first 3 digits are odd? Probability. How do we do probability? Okay. The number of successful or favorable trials divided by the number of total trials. So I know that 10 permutation 7 is the total number of ways that I can make a code. How many ways can I make a code where the first 3 are odd and the next 4 are whatever? This was called combinatorics, and it's when I take probability, fundamental counting principle, and permutations or combinations, and I jam them all together in the same problem. How many odd numbers are from 0 through 9? So if there's 5 odd numbers, does the order matter? It's a code generated, right? Yes, it's randomly generated, but if I have a code that starts 135 versus a code that starts 315, those are different codes, right? Like different phone numbers. Who has the little electronic keypad lock on their car? Okay, those were a thing back in the 90s, early 2000s. Okay, it does matter. It is a permutation. It's a code. Okay, who's got, instead of a swipe, you have a actual like pin to open your phone. If your pin is 4182, is it okay if you instead do 8124? No, it's a code. The order matters. So I have that many ways to get my first 3 are odd. how many ways do I have to get the next 4 digits? How many digits remain to choose from? It doesn't say that the next ones have to be even. Not 9. Remember, it says you can only use each digit once. It doesn't say they have to only be even. There are 10 total digits. I just used 3 of them. 7. And I have to choose 4 more digits to fill out the code. So what you're doing here is you have 1, 2, 3. 1, 2, 3, 4. I'm saying these are odd. These are whatever. Okay. So for these 3 to be odd, I take my 5 odds and I will choose 3 of them in an order. For these to be whatever, I'll take the remaining 7 digits, because I already used 3, and I will order up 4 of them. And then I divide by how many total ways this is possible. Jam it in my calculator. This is where a right view calculator comes in real handy. If I do not have a right view calculator, then I need parenthesis, I begin the numerator. Parenthesis, I start the first permutation. 5 permutation is 7. 3, close the parentheses, I am done with the first permutation. New set of parentheses, I start the next permutation. 7, permutation, 4 of them. I close the parentheses to say I'm done with the permutation. I close the parentheses to say I'm done with the numerator. I divide by. The next. So I got to do that if I don't have a right view calculator. What a right view does is it allows me to type it exactly as it was written. On the fraction, I'll have 5 permutation 3 times 7 permutation 4 over 10 permutation 7. Because, y'all remember, if I get this, I can go to math and say, please turn that into a decimal. Okay, they need more. This is why we don't use decimals. 0.08. Math. Oh, okay, it's 1/12. If you do enough 3s, it'll turn it into 1/12. All for sure. I'm putting myself on the board. That was bad. Jesus. I'm putting myself up there. Oh, wait, I still owe you one from yesterday. I owed them 2 from yesterday. Okay. Turn this to a fraction, but I said decimal. Wow. I'd like you to write all the formula for this. You take how many things of category A are possible. Okay, I'm going to put P up here. It's either permutation or combination, depending on the problem. It works both ways. And how many do you choose from category A? Times how many things do you have for category B? Permutation. How many are you choosing from category B? But the thing is, you're going to keep doing that for however many categories there are. I can get super specific. What is the probability that I have a hand of 7 cards and it includes exactly 2 lands, 2 pump spells, 1 infect creature, and 1 counter spell? I'm a magic dork, okay? Like you can, for every one of the categories, you're going to need one of these. That's why I got the ellipsis at the end. And then you divide it by how many total objects you have. How many are you choosing for your group? So in this case, our first category was odds. I was choosing 3 of them. My second category was anything. So what was left? How many are you choosing? My total digits, and how many were I choosing for my code? Okay? That's how you do combinatorics. So for example, I think we need another one of those because it's just been a while. We have in here, how many juniors? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13? 13 juniors, 11 sophomores, right? We didn't have any seniors in this class. Okay. What is the probability a group chosen at random has exactly, and they'll say this, exactly, 3 juniors, 2 sophomores? Figure it out. In this room, we've got 13 juniors, 11 sophomores. What is the probability I choose a group of 5 students and it has exactly 3 juniors, 2 sophomores? Combinatorics allows me to find very specific probability. If you've heard of a hypergeometric calculator, what it does is have a series of these, like a descending series of these problems, and adds them all up. This is also why Game Club kids get mad playing Texas Hold'em with me. See my eyes roll up in the back of my head and I go in the tank, they know I'm actually doing the probability on it. That's, if you listen to any of those like World Series poker guys, if professional poker players will actually memorize tables of probability, because you memorize probability tables, you know, if I have this, I see these cards, there is literally a this chance of this happening. It is the mathematically correct decision for me to fold. You play the probability. And if everyone is doing that, then the edge goes to who can get in each other's heads. Who's got the tells? We played Resistance the other week, and I'll tell you what, Hainsley cannot lie to save her life. Category 1, 13 juniors, Okay. Now I lied. Does it matter who's getting chosen first? Okay. Who remembers what that's called? The C thing. Combination. Okay. Again, I'm just kind of assuming that we all did this before. I'm going to switch over to combination because the order does not matter. Now, if you did permutation, what you just did was, what's the probability that I pick a group of 5 students at random and assign them a specific task? If you are chosen first, you are going to go sort cards. If you are chosen second, you are going to go out to my truck and get the big bag of groceries to bring in. If you are chosen third, you're going to bring this down to the office. A specific task, so order mattered. Okay? So 13, I will choose 3 of them. There are 11 sophomores. I will choose 2 of them. Grand total, there are 24 kids. I will choose 5 of them. Okay. Remember, these will be tiny. This is the probability of choosing a very specific outcome. Now, where you start getting into larger combined probability is when I say, what's the probability that I choose 3 or more juniors? Now I'd have to do this for 3 and 4 and 5 and then add them all together because they're distinct events. So we did this back in the day. This was new in Algebra 2. We have this year moved this down to Algebra 1. We'll see who remembers what. Combinations. So a permutation is when order matters. For example, the back table that will not stop talking and might need to get split up. If they are sitting in this specific order, does the order matter, or does them just being at the table cause the problem? Okay. So if I have Jack and Jaden switch places, order matters if that solves the problem. If just having them back there doesn't solve the problem, that's a combination. In a permutation, order matters. In a combination, it doesn't. So I need to get rid of the repeats. I have a GE, I don't need an EG. I have an HE, I don't need an EH. I have an FG, I don't need a GF. I have an HF, I don't need FH. I don't need HG. So to get rid of all of those extras, to get rid of the repeats, all we do is modify the permutation formula and say, I'm also going to divide by R factorial. Because if I have R things that I'm choosing, then I will have R factorial repeats. Okay, now there's proofs for all of this. I don't think we even show them to you in Algebra 1 and 2 because the proof is a little esoteric, but the concept is, oh hey, press this button. Right next to permutation. Y'all know where it is? Okay, so there you go. One of them is basic combination, the other is combinatoric. Figure it out. Rah, rah. Why do cheerleaders only know even numbers? 2, 4, 6, 8. There's a difference between like spearfish cheerleaders and competitive cheerleaders. Competitive cheerleaders are friggin' athletes. They do some bonker stuff. Just ninja flips, jumping 30 feet in the air. Bunch of Jedi. Give you a little bit of a head start on B. They're C's because these are combinations. There's nothing in the wording that says the order mattered. There's nothing in the wording that says it's an arrangement. So I'll use combination.
I don't know why I wrote the big old equation. Because it's just a flat answer there.
Yep, first one is just straight up NCR. Until the publishers from this book also are used to larger metro area schools, because anything that involves classes, they almost always leave out freshmen. Freshmen. Freshmen don't even belong on JV. Give them C squad, right? I take that back. Some freshmen they got skill. Some freshmen do. There are 16 kids total. We're choosing 12 of them. Okay, how do I set up the top? 7, we're choosing 4 of them. 5, we're choosing 4 of them. I want to ask about that last one. 4, choose 4. There are 4 kids at this front table. How many ways can I make a group of 4 kids from this table? A group, not an arrangement. 1. Okay. Because it's going to happen, because someone's going to screw this up, I would like you to type in, what is 4 choose 5? 0, right? I have 4 kids. How many ways can I make a group of 5 kids? 0. There are no ways to do this. Okay? So just be aware of that if you ever goof these up. Big number, then small number. Okay? And I jam the whole works into my calculator. What did we get? 5 over 52 or about. Okay. Which is going to go to something that I don't know if we've explicitly talked about in here yet. Y'all, you went through Algebra 2. You know what pi is. You know what e is. You know what I is. You know how to simplify radicals. You know how to simplify rational expressions and write compound numbers. We do not go to decimal town in here. Okay? Decimal town has a lot of error in it. So if you can write it as a rational expression, if you can write it as a simplified radical in terms of pi, I, or e, you will do that. And then, if you want to put the decimal approximation next to it, that is fine, because that's the one that most people understand. Okay? If you want a real good way to make sure that people spit in your food, you get your total, and then you get your tip, and you say, and then just leave the bottom blank and make them figure it out. Now that might be the exact amount that I want to give them, because I want to give them $9 plus that fraction of a penny. Okay. I did that to a former PreCalc student. She handed in her final and said, "Can I cry now?" Because I kept telling her you're not allowed to cry in class. I handed that to her at Common Grounds. She screamed and ran away, and had her coworker do it instead. But y'all know you can just take the subtotal minus from the total. Like, that tells you what it is. But that might be an exact value, but if I go into Necht Home Center and I tell them that I need 38 square root of 5 feet of 2x8s, they're going to just grunt at me and like pick their nose or something. Okay? But if I tell them the exact amount that I want versus a decimal approximation, decimals are what we usually use in real world context because it's close enough. This is a math class. We need to be precise, otherwise the math might not work. So please, write the real answer and then the decimal approximation with it. Okay, stats. You have been doing one variable stats since at least middle school. Okay. Now, whether you've seen it in this notation or not, that's a different matter. Measures of central tendency. A measure of central tendency is, well, this number is a good representation of what is typical for my data set. Mean, median, and mode all have their own merits. Mode, I'll tell you right now, hardly ever used in statistics after Algebra 1. Mode is just whatever happened the most. What I do want you to write next to that, though, is you probably remember getting problems all the way back in middle school where you had like 5 numbers that all happened the same amount of times. So you'd write them all. What we usually have is one mode. We have bimodal, 2 modes, or we just say no mode. After bimodal, usually statisticians just don't care. Okay? Mean and median, I hope we know those by now. Mean, also known as average, add them up, divide by how many there are. Median, whatever's in the middle. What happens if I have 2 numbers in the middle because there was an even number of them? Find the average of that. Also, it's the midpoint formula, is to add up and divide by 2. Have we ever seen those symbols, though? That's the catch. Okay. This is capital Greek sigma, capital Greek S, for the sum. Little Greek sigma, little O with a hairdo, is standard deviation. We'll get to that in a minute. Now I ask the terrifying question. Who has never seen sigma before? Okay. Who has never heard the word standard deviation before? Okay. The last couple of years have been a wild ride, so I gotta ask. This little fella over here is called mu. Like kitten, mu. Mu. They're all Greek letters, okay? Little Greek letter mu. Okay. This is a population mean versus a sample mean. This is the one that you're going to see. X bar. X bar is the mean or the average of a data set. Okay. It means sigma is sum. It means add up the values and divide by how many values there are. Why would I want to know both mean and median? What's the difference? Well, they both tell me about a typical number. Please put that note next to it. You use a median when there's outliers. A mean or an average really gets thrown off by outliers. Big time. Example. Spearfish is a very privileged community. Y'all don't understand this. I know of 2 students right now who didn't have food over the weekend. Literally, nothing in the house. Didn't eat for a day. And then we got kids up on the hill who are living in a $1.3 million house. Okay? What happens when you take the average home value or the average income in Spearfish? If you got a bunch of data that's sitting down here, but then you got a few data points that are way the crap up here. Do you know that just the existence of Jeff Bezos throws off the average American household income? One person literally moves the needle for the whole country. Okay? So a mean really messes with things. Median, that's why you'll hear stuff like median household income, median home value, because it takes those outliers and says, yeah, screw off Bezos, these. Okay? Range. Please tell me you know what range is. Range, maximum minus minimum. What's the biggest? What's the smallest? That is my range of values. See, if measures of central tendency are a number that represents what is typical for the data set, the measures of spread tell me how spread out my data is. If my data is really spread out, it is considered inconsistent. If my data is nice and clustered together, it is considered very consistent. Okay, I know we got a number of athletes in the room. What happens when you got that one kid who, you know, when they're on, draining threes all day long, but they're horribly inconsistent? You know that if they break up with their current significant other, they just ain't doing diddly the next game. And they have a very turbulent personal life, so who knows what week it's going to happen. A person who is consistent or not consistent, a data set that's consistent or not consistent. This tells me how spread out that data is. You got that kid who might score 20 points in a game versus nothing. Depends, right? Variance we very rarely use because typically variance is just used to find standard deviation. In fact, even in your homework, if it says find the variance, don't. Like, you just use it to find standard deviation. There's other applications for it later if you go do college stats. Standard deviation, on the other hand, That one we should know. Whoa, 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 whoa. Standard deviation is what we learned back in Algebra 1, or Algebra 2. We moved it to Algebra 1 now. It's tough to find manually. Read the symbols. Sigma, add them up. X, my data point. Mu or X bar, the mean. How far is your data point away from the average? Square them, add them up, and divide by how many there are. This is, and then square root to undo that, so you put it back in normal land. A standard deviation, if you need to write next to it in common lay terms, is, on average, how far away from the mean is my data? It is literally how far away, how far spread out is my data. Standard deviation. Standard deviation is the one that most statisticians will use. The whole like mean, median, mode, box and whisker plots, interquartile range, that's kind of kiddie stuff. Statisticians love doing standard deviation. And luckily, we learned in Algebra 1 and 2, you don't ever have to find any of this manually again, because it's all just a button on your calculator. Okay? Who, excluding the ones who have been in my room, knows how to find all of this data, all of your mean, median, mode, standard deviation, interquartile range, box and whisker plot, find all the stuff from a data set on your calculator? Yee! Okay, let's do it. Instead of this data set, let's find out who in the room is actually not normal. Who all knows their height? In inches. So if you were 5'6", 5 foot times 12, 60 inches, plus 6, you are 66 inches. Everyone know your height? So we got a couple of tall ones in the room. I want to see who's actually not normal. Okay. Everyone got your calculator out? Stat, edit. Stat, edit. If we are confused where the stat button is, boy, do you got a lot to learn about the calculator. Well, you know your own thing. Okay. Again, all of these directions are based on TI 84 or 83 because that's what we have in the classroom. You do not need those. You can do this on other calculators. My 36 Pro here, it's like 18 bucks at Walmart. This will do everything that I'm about to say. Okay? 18 bucks. You do not need a graphic calculator to do this. We're going to go around the room. Make sure you can keep up with the bouncing ball. Your height in inches. Go. 75. Jesus, dude. Okay. 70. 69. Obligatory nice. 63. 64. Oh. Enter 65. There we go. Didn't register that. 72.
Probably like 70. No, probably like 67 or something. I don't know.
You don't know how tall you are. Okay. Stand next to someone who's about your height. Figure it out. 70. 70 again. 70 again. Jeez. Land ho! God, you guys are huge. 70.
71. 74. 71.
Okay, I'm going to stop there. Hold on. Is everyone keeping up? You should have all 24 data points in here. I am currently on kid 18. Okay, Finn.
66.
What is 66? 68. 68. Say it loud and proud so everyone can hear it. And we already got the front row, right? Okay. Wait. And then Matthew. All right, we'll say 67 just for grins. And last I checked, I was 5'11", so 71. Okay. If you got a bunch of data in there, I am honored to be 5'11". My mom is 5'2". Like, the fact that I'm not a pygmy with peg leg feet, like, ooh, stat. If I want to know all of my one variable statistics, stat calculate. And look at what option number 1 is. Now, on TI-84, it's going to have this cute little pop-up menu. It's going to ask you for a frequency list. A frequency list is more like a table. Instead of writing out 66 5 times or however many we had, instead of writing 70 5 times, however many we had, next to 66, I would say 5. Next to 70, I would say 5. Okay? So I would put in list 1, and then frequency list would match and say I have this many of that. So I didn't have to type so many. Okay? Since we did not do that, don't worry about the frequency list, just calculate it. Doop, doop, doop. And it tells me that the mean, the average person in this room is 68.96 inches tall. It tells me the sum of my data. If we stacked all of us, toes on head, a big old pile, okay, like all of the I would die for Riley's guys, okay, we would be 1,724 inches tall. Okay? Down here, though, this is my standard deviation for a population. This is my standard deviation for the sample. Okay? There's a slight difference in the formulas. I'm just going to tell you right now, and maybe you make a note of it. We are always going to use our sample. Now, someone could argue that our current population is our sample, so those two should be the same. There's statistical theory behind it. Don't worry about it. You'll learn it when you're older. Okay. Down below that, it tells me how many data points I have and minimum Q1. What is Q1? Quartiles. Does anyone remember doing box and whisker plots? Okay. So if I had a number line that goes from, I'll say 60, 65, 70, 75. I don't think we got anyone this tall. Okay. To make a box and whisker plot, nice and easy. You put your minimum at 63. You put quartile 1 at 66. You put your median 69. Your quartile 3, 71. And your maximum, 75. Look familiar? Okay. These are also called the 5-number summary because of that. The 5-number summary tells me how spread out my data is. Your median we know is the middle. The quartiles are at the middle of each half. So that means this area right here, this is 25% of our room. This is 25% of our room. This little box, these 2 inches here, is 25% of our room. Okay. Quartiles are about percentage of data, not percentage of space. So a quarter of the class is within 2 inches of each other in terms of height. You will never have to find any of this manually. You did that or should have done that in Algebra 1 and 2. You dump it all into list 1, calculate your 1 variable stats. Okay. When they want the measures of spread, what are those 3 again? Measures of central tendency was mean, median, and mode. Measures of spread, how far spread out my data is. Standard deviation, variance, which we don't really care about, and range. Interquartile range is also a thing. It's quartile 1 to quartile 3. So I'm not going to bother with that. Right, there's our thing, there's our thing. Okay. So if I'm comparing them, the way that I'll split things up is to compare them physically as a graph. If I wanted to separate everyone by the binary and say girls over here, guys over there, compare these heights, compare those heights. I would do that by putting all the single ladies and then all the guys over here, and I would go and make 2 different sets of stat plots. Y'all remember those? Second stat plot. Now you probably mostly use this to do scatter plots, but look at one of the other options. Make a box and whisker plot. I can use my calculator with the box and whisker plot. Now that my plot is on, now I'm going to be plotting statistics. I can zoom into my statistics, and it will give me my box and whisker plot, and I can even trace it. Come on, Frank. I can even trace it and look at what it's saying at the bottom. Shows me that 5-number summary. Okay? I'm showing you all this because we're reviewing all this. You should have done this a long time ago. Okay? You should have been working with basic probability and statistics. Okay? If you haven't, if a lot of this sounds absolutely foreign, that means it is your responsibility to come in and get some extra work with it. It's not difficult, but you got to know how it works. Standard deviation. The reason we use standard deviation is to find out who's actually normal and who's not. Come on, Frank, why are you being so slow? Slide fix templates. Yoda. There we go. There we go. Y'all seen the bell curve before? Okay. What the bell curve is it takes your mean and puts it in the middle, and then you use that standard deviation to +1 standard deviation, +2 standard deviations, 3, and so on. Okay. Nice part about standard deviation is it tells you literally what is normal and what's not. I want you to make a note somewhere on there that anything 3 or more standard deviations away from the mean, those are my outliers. Because those are literally, when you combine them, a whopping 0.2526% of the population. For someone to be abnormal, they got to be really abnormal. Otherwise, everything in there, these would just be considered low, high, low average, high average, average. Okay. So when you hear things like, you know, oh, well, I'm just a freak. I got big feet. Like, really? Do you actually? What if we went with everyone's shoe sizes in here? We don't have time. We did shoe sizes at the end of Algebra 2 last semester when we were doing all this, and found out even the kid who was wearing like a size 3 toddlers or whatever it was not abnormal. They were really close. Or no, wait. Wasn't she? She was really, really close. Like just a hair out. Okay? Think about your shoe size. This kid was wearing a 3, and they were just barely an outlier. Okay? So, we don't have time to go through everything. I hope that you know what things are and what they aren't. The last part here, y'all, dump all this into list 1, dump all this into list 2, plot 1, plot 2, look at their box and whisker plots. Tell me which one is more consistent, which one is bigger. Cumulative, relative, frequency tables, y'all, it's a bar graph. It's a table and a bar graph. Can you make a table that shows me how many scored up to 15? How many scored 16 to 20? How many scored 21 to 25? And then turn it into a bar graph. Okay? If you got questions with it, if you don't remember, didn't take, or failed miserably, Algebra 1 and 2 prob stats, ask questions, use your mind. Very few of you are doing this.